is the class of analytical chemistry and lecture 1. And in this that chapter, that MCH-1 will follow several things. As you know that analytical chemistry is the that is a practical subject. Okay. So what do you mean by practical subject? You have to calculate lots of things. You have to study about that particular elements, its behavior, and all the things, right? How much amount is present in that particular that is substance. Suppose if we say that all of you have well known with the various type of salts like barium sulfate. So if we take some amount of barium sulfate, and what is the quantity of barium in that barium sulfate, we can calculate. So in the in analytical chemistry, you have well customized with the titration methods in your past degrees. So these are coming, all these things are coming under the analytical chemistry. So spectroscopy, have you heard about the term spectroscopy? Have you heard?
Yes, sir.
Okay, that spectroscopy is a type of process which is used in this analytical chemistry. So that's why it is a very important and practical subject, and the part of the chemistry practical subject, and a part of the chemistry of that one, analytical chemistry. So first, in the first slide, you will see that thing is there, that analytical chemistry lecture 1. Under these various things are there, and I, Dr. Pratap Bhatpanda, who is going to teach you about this analytical chemistry. You may have multiple doubts or something else, so that come to time we'll face. Okay, so let's start with the today, that analytical chemistry lecture 1. So usually I have a question, and also you do have the question in your mind. What is the analytical chemistry? What best what facts we'll discuss in this analytical chemistry? What exactly it's a different thing? How chemistry? We know that before we have heard about the physical chemistry, organic chemistry, inorganic chemistry, like this. But right now our target, see that when you go up and up and up like that, degree will be higher, then your part of the subject will be squeezed. You have to emphasize on the specific area of the particular subject. Like that, you people are now the part of the chemistry, and we are going to read this analytical chemistry. So in the latter, that is, you will go time to time, will go very specific things. Okay, so in before that degree, you have studied that a titration, but what is the process of titration? What exactly will you do? That we have not studied. We have do only the practical of the titration and all the things. So this is the practical things. As you know that I told you that analytical chemistry, the titration is the part of analytical chemistry. So you just imagine what you have done in the practicals, in the titration, how you have find out the strength of acid, strength of base. So these are coming under the analytical chemistry. So this is obviously, this is a area where we can read the very specific things and very particular thing. It is an interesting one. It's a much more interesting one. This is the what are the equipments you use, and where you can use which equipments. So if we see, if we use the burette, whatever you use in case of titration, if can you use that pipette to picking that strong acid? It is not possible, right? So thing is that so many things are there which is confusing that students in the several segments. So in the analytical chemistry, we'll have to understand first what is that analytical chemistry, what is the definition, how the things will be arises, what are the facts will be analysis, like this. Okay, now we'll come to the, so this is the first slide and second slide. Now see, my question is, what is analytical chemistry? So we have to understand what is analytical chemistry. So see, it is the science of obtaining, processing, and communicating information about the composition and the structure of matter. If we take any matter, anything else, suppose if we see, if we think about a particular that is element like sodium, and we tested it for the several things, how its behavior. If we when dry, you have gone to the different salt analysis. If we put the sodium in front of the flame, like that is flame, the color of the flame will be changed. It is, if the flame color is blue, then it will turn to the yellow, right? So this is the spectroscopy. Why? What happened there? What happened exactly there that the color of the flame changed? So we have to study in the analytical chemistry. So this is the thing that what we are exactly studied in the case of analytical chemistry. So that is, it is the science of obtaining, processing, and communicating informations about the composition and structure of matter. So if you take any kind of a sample, you have to use, then sample you have taken, you have to use the techniques, the process, and what the facts arises, what is the present, what different things are present in that composition, in that sample. So that is known as the composition. So you can find out the composition by using this analytical chemistry. Okay, so if you go to the down, there you will like using mass spectroscopy. I told you that one spectrometry here is the type of a spectroscopy method. Using mass spectrometry to measure charged particles to determine the composition of a substance. So if you use the spectrometry, so you will see that what kind of charged particles are present in that particular matter. That is the analytical chemistry. So this is the analytical chemistry, that what exactly we will study. See, this is not easy one. This is very actually that you have to understand the things what is there. Okay, if we come to the next slide, that is analytical chemistry, having that if the center part of this is analytical chemistry. Okay, C is mentioned here, the analytical chemistry, and that there is analytical chemistry means analysis, applications, theory, and synthesis. All these four factors composite together to give the analytical chemistry. So under the analytical chemistry, you have to read all the four factors. What is the theory associated here? What are the synthesis processes are here in the analytical chemistry? What kind of synthesis process you have to use? Whether it is titration, galvanometers, that spectrometers, whatever, potentiometers, what kind of process you have to use, and what is the analysis, what results you got, right? After the analysis of these things by using this particular processes, what you analyzed, what you got, okay, then it's application. Until unless if you don't know what is the behavior of a particular substance, so we cannot apply, we cannot use anywhere else. So analytical chemistry means to find out the reality, what is hidden in that particular compound, where we can use it, where we cannot use it. So that is the most important part, because you know that chemistry of the application part, this is the application part of the particular the chemistry subject of chemistry. Okay, if we come to the next slide, then types of analytical methods. See, this is an important area for your exam. The questions may arises about that this particular thing, types of analytical method. Okay, now see, the analytical methods can be divided into three major groups. These are the three major groups which is associated with the analytical method or analytical chemistry. Okay, so what are they? The chemical method, by using the chemical method. Second is physical method. Third is physico-chemical methods, means combination of physical method and chemical method. Three methods are most important for the analytical chemistry. You have to memorize the three methods: chemical, physical, physico-chemical methods. Perhaps might be that at the end of your chapter, there is lots of questions. You can answer. If you follow these slides, you can answer all the questions. So this is the physico-chemical methods. The chemical methods are classical methods. Chemical methods are classical methods. This is the important one. So out of three methods, which method is the classical method? So chemical method is the classical method. Why it is classical method? See, there is classical. I'll come to the classical method and all the things. So chemical methods are classical methods, whereas the physical and physico-chemical methods are known as instrumental methods of analysis. You have to understand now, two terms are there. One is a classical method, one is instrumental method. Means instrumental method means we have to use the scientific instrument to calculate what is analysis and its results, right? We have to analyze by using the instrument, different kind of instrument. By using different kind of instrument, we have to analyze, and we have to find out what is the present, what is the amount of a present of a different compounds or components in that particular that is substance or sample. And classical methods, why it is every time it is the lateral. In earlier time it was there, and right now it is we are using, and in the future also will use. Suppose if we put hydrochloric acid into the zinc, suppose zinc is the metal, and if we put the hydrochloric acid into the zinc, then what will happen? Then hydrogen gas will be evolved and zinc chloride precipitation will be formed. So this is the classical method. But if you go to any, if you put the any zinc on any instrument spectroscopy meter, and if you put any kind of any kind of a sample on the spectroscopy meter, then that will be graph will comes out. So there is no use of chemical that method. It is electronical method. So instrumental method is like that. Okay. So types of analytical methods is three types. One is your chemical method, second is your physical method, third is your physico-chemical methods. Again, that chemical method is always known as your classical methods, and there are chemical methods as well as physico-chemical methods. These are two are known as the instrumental methods. Okay. You're coming to next slide. You have to, if you come to the next slide, you'll come. Okay. Now, what will happen? In analytical chemistry, we often determine the amount of a chemical species from mass measurement. What is actually that? Now we will come to the point that what is the analytical chemistry, use of common analytical chemistry. What will be your job if we choose the analytical chemistry? What in the field of that job profile or working profile of the analytical chemistry in the chemistry segment? What will be your job? Job is to determine the amount of a chemical species, which chemical species you are searching for. What is the amount of that species present in that particular sample? You have to find out the mass measurement. It is known as the mass measurement. What is the amount of that particular species is present in that particular sample? You have to find out that one. That is the job, that is the work schedule of a analytical chemistry person. Okay. Now we'll come to the second point. For such measurements, kilograms, grams, milligrams, or micrograms are used. This is the unit, right? If you find out any kind of mass, it may be in kilogram, maybe in gram, maybe milligram, microgram, whatever the unit, you know better. It is the on the basis of that you can convert. If it is a microgram, it is milligram, you can convert into kilogram. So this is the decimal point of only one thing, the calculation of a decimal points. Okay. Then if it is liquid, if it is that is your solid, you can use this kilogram, gram, like this. Okay. If it is liquid, you have to use liter, milliliter, microliters, etc. Unit of volume is liter and defined as the exactly 10 to the 10 meter cube, right? So you have to conversion, you know better. No need to say about the conversion. I have little bit of idea I gave you that regarding the units and all the things using of units in the that analytical chemistry, but you know better this one. This is, you have nothing to say in this case. Okay. Next, if you come to the next slide. Okay. What is the scope of analytical chemistry? This is the important fact. This is the important. Why we are studying the analytical chemistry? I am not only going to teach you that what type of processes is there, how can I determine all the things, but as we are going to start the topic, so it is my motto that why I'm studying this analytical, why the IGNOU has given us the space to read this analytical chemistry and to what to do after this. Okay, that is the scope. So now the thing is that analytical chemistry plays an enormous role in our society. What type of role? Such as the drug manufacturing, right? You know that different medicines are there. We are using different kinds of medicines, and better things, you know that what is the composition of different types of medicines. So it's essential. So analytical chemistry gives up the, I told you in the sample, what is the amount of a particular substance is present. We have to extract that substance, how much amount of substance we can get from that substance, that particular sample. So that is the work of analytical chemistry, right? So if you work on that, if you choose your field, the analytical chemistry, so you have to think about the drug manufacturing. Okay. Second, process control in industry. Process control means different types of different kind of if we say that nowadays biodegradable that polythenes are coming out, right? So this is the work of what type of that the sample will provide this, what type of that a particular species plus constituent particles which can provide us biodegradable polythenes. Okay, that is essential for the environmental point of view. Okay, now we'll come to the next use. What is the scope where you can use this analytical chemistry? Environmental monitoring. Okay, that is the most important thing, which is what kind of substance is present in this particular area. That's why that effect of that soil is means that is deteriorated day by day. So what kind of species, what kind of that sample is present in the air, that's why this pollution is there. So this is the environmental analysis. You have to collect the sample, you have to test it, then you have to see whether it's bad for the things or good for the things. Okay, now the things, the medical diagnosis like cancer. As you know that nowadays, I don't know that whether my that opinion is correct or wrong. So nowadays much more cancer patients we are observing, right? Much more kidney patients. So why it is happening? So what is the main that objectives? So by using, you know that for the cancer treatments, so cancer treatments elements are essentials. For gamma rays production, elements are essential. So that kind of things analysis, for the analysis of that kind of things, we need analytical chemistry. Okay, food productions. Now in front of the food production, forensic survey, any kind of criminal activities if happen. So what type of particles present inside that particular crime scene or anywhere else, that is forensic survey. So that is also, you have vast opening in this case. Okay, it is also great importance in the different research areas. Now see, I told you the broad, in the broad sense, this is the scope of analytical chemistry in your life. As you are taking part in this, as you are going through this analytical chemistry subject, so it has vast opening. I told you the broad sense. If you structurally, if you open this one, you will get the better sense of this one. Okay, if you come to the next slide, then in the next slide we have to understand steps in analytical chemistry. Okay, what type of steps we will follow in case of analytical chemistry? First thing is, we have to understand what is the problem, right? Where is the problem? What is the problem? So we have to understand that one. So that is define the problem. So we have to understand what is the problem. So define the problem is the most important. Okay, so this means that the analyst should know what is the information required. I told you, I have to understand what has to extract. Suppose I am telling you about that barium sulfate or aluminum chloride. I have to understand what has to find out. Whether it is, I have to calculate about the aluminum, or where I have to calculate about the chlorine. On the basis of that, I have to follow the process. Right? Without understanding the what is there, what I have to define, what I have to understand, what I have to do. So I cannot analysis the things. I have to first understand what is my target. That is the definition. Okay. So the type and amount of a sample, you have to understand. If I am telling you, you have to find out about the what is the that the amount of aluminum is present, and I provide you the barium sulfate. So is it possible to calculate the that what is the amount of aluminum is present there? Because you got the sample barium sulfate. You have not given, you have not assigned with that sample your aluminum related any kind of aluminum sample. You got barium sulfate, so you can find out the barium, but you cannot find out the aluminum. So that's why it is important the type and amount of sulfate. Okay, the type is I told you the amount, type and amount. What is the amount? Means it is in a kilogram or gram. If it is huge amount, then you have to calculate in the kilogram sense, right? Okay, so and the precision and the accuracy of the results. What are the steps you have to follow? In the steps, what is the method you have to follow that you can get the best accuracy or best amount of that particular species, particular that what exactly you have to give in to find out. Okay, the analytical method which can be used to achieve the results. Suppose I am giving the liquid. Okay, I have given you the liquid and I told you just to follow the potentiometer. It is not possible. We have to go through the titration method. If I told you to find out that what is that to find out the molality of this liquid solution, but you are not giving by the titration, means any kind of a chemical methods is not provided by you. It is not possible. So you have to think what is to do, what is the that for that what is essential, and for that what is the procedure, and for that what is the steps you have to follow. All everything's are synchronized each by each. This is the research division. So you cannot means mix up all the things, and if you mix up, so lots of problem will be arises, and problem means so you cannot control that things, right? So you have to, it is my suggestion, being a means a chemistry person, it is my suggestion. First you have to think, you have to understand what is given, what has to do, what is the procedures, what are the steps you have to follow, what calculation you have to fix, and what is the what target result you want actually. So you have to go through this, then you have to just try to do the work, right? Step by step process, what are the processes are there, what are that chemicals you used, or what type of instrument you have to use. All the things you have to step by step you have to follow. So this slide is all about that. Next, if you go to that next slide, it's a define the problem. If you come to the, then if you come to that precision, okay, that means, see that if that what do you mean by this? So it describes the reproducibility of a result. Okay, now accuracy. So what is this? Describe how close a measured value is to be true value. That's most important. That's accuracy. That's why we have scientific notations. We cannot make haphazardly. We cannot calculate the things in the rough way, rough manner. We have to do in accuracy method. Suppose I'm telling one thing. Suppose that right now that samples are collecting from the different your planets like Mars. If you are part of the ISRO, okay, so you have to calculate, you have to fix that sample came, and you are part of the NASA, you have to part of the, you know that ISRO is doing fantastic job, and you do have best career in case of in that area. ISRO, if you're good analytical chemistry, so that means you have a best option in that ISRO. Why ISRO? Because now the samples are coming from the different zone, and we have to analyze what are the elements are present in that, what are the behavior, what is the structure, then on the basis of that chemical properties, because it's a thousands years, crores of years that particular that matter is there. So when the matter came out, and we have to analyze on the basis of that calculation, we can fix the things, we can understand the things, where what is there and what probability will be there. So then we'll reach the accuracy point. So it is the job of the analytical chemistry person. Okay, now see, if we'll come to that slide, you'll understand that high precision, high accuracy, high precision, low accuracy. These are things that low precision, low accuracy means this is your what kind of things you have to do in case of analytical chemistry. Okay, if you come to the next slide, you have to understand often a representative sample. But actually this thing is technically that important thing. Now if you read this one, a chemical analysis is usually performed on only a small portion, right? You have a big amount of that area, but you have to take a little bit of things. Okay, that is the most, from that little bit of things you have to analyze all the things, you have to calculate all the things. So portion of the material to be characterized is very small, specific area of things you have to take, you have to work on that. You cannot take the 5 kilos of materials and you can use that one in that your experiments. You have to take only some few grams of that material, and you have to calculate all the things. Okay, this person need to have the same characteristics of a whole sample. If you see that you have taken a sample, that sample is there, but that the whole particular area having different other samples, but you have collected simple samples of that one. No, that you cannot calculate that things. Okay, you have to collect the whole sample is the similar type with the what sample you have taken. You cannot take that from other samples. You have to take a small bit of samples, right? So what sample you will test, and you can tell what are the amount of present in that particular sample. It is not possible. You have that sample should be equal or same what sample you have taken for the test. Then you can calculate. Okay, in order to obtain the actual results. So neither there will be that results will not get the particular results. That is the work of, that is actually what I told you. This is the sensitive part of the analytical chemistry person. Okay. This particular area of workings that is it's very difficult. Okay, so then come to the point. What to do? How to prepare the sample? This is particular things that I am telling you that regarding that. Analytical chemistry, what is the things you have to do, what you have to do. Then we'll come to your things chapter, what is written over there, what type of that analytical process will there. Then sample preparation, how to prepare a sample. This is the practical knowledge. I told you that this is the practical, completely practical based things. So without practical knowledge, you actually very difficult to do these things. Okay, so we have to understand what is, how to do the preparation, how to prepare the sample. Okay, so most analytical methods requires a liquid form of the sample rather than the solid form. First thing point, most 95% that sample should be in the liquid form. You have to, maybe it in solid form, that does not matter. You have to make it liquid form. I will remind you. So you will find out that strength of oxalic acid in the titration if you have done in the graduation. Okay, so oxalic acid method. So oxalic acid means oxalic acid usually in the lab that is in that solid format, right? So you have to make it the liquid format. It's like that. Sample should be in the solid format, maybe liquid format, maybe in solid form. That doesn't matter. But if it is in solid format, you have to convert it into the liquid format. Therefore, sample need to be dissolved quantitatively and may also be diluted to the concentrated range of the method if they are present in a high concentration. This is important. Okay, so that means, see, if you take zinc chloride and put in the water, if you take the zinc and put in the water, okay, will it be hydrolyzed? Will it be dissolved? No. So that is the issue. We have to make that particular, where we have to understand the chemical properties, whether it is dissolved in this substance, because I have to bring into the liquid format. So liquid form, that sample is solid, we have to bring into the liquid form. So we have to understand that what is the nature of that particular solid, where it will be soluble, where it is not, and noting is the most important. You have to try. You have to preparation. You have to prepare that particular solution by using different type of preparatory method. So you will write where that is soluble, then you have to write down it is soluble. That is the research part. Okay. Next, chemical separation. Okay, the sample may contain solutes which interfere with the determination of the analyte. If it is the case. If it is the case, the analyte should be separated from the sample matrix by an acceptable procedure. Okay, so that means solute and solvent, when you add any kind of that is solute, any kind of that solvent to the solute, and it is dissolved. Okay, that should be interfere. Interfere means there is separation area, means macromolecules and micromolecules should be there. Then micromolecules and macromolecules can be separated by the suitable procedure. It may be crystallization, may be filtration, may be any kind of process you can maintain, but it can be that is separated. If separated, then we can go to the another things. Okay. Next, we will come to the next slide. Perform the measurements. How to do the measurement? How to do the measurement? So means time to time it will come. This is the procedure. Time to time, how to, you have to measure the amount. What is the amount of present? I told you in the early the slide that what is the job of this. This we have to find out. It is in kilogram, gram, milligram, or liter, milliliter, whatever things you have to use unit. So that means you have to measurement. Measurement is the important part of the analytical chemistry. This is most important. This implies conducting the analytical procedure and collecting the required data. So that means you have to procedure, you have to maintain, you have to find out the what is the amount of present over there, then calculation. Okay, so I told you that formula should be there. You have to put a particular formula to for the calculation. It may be simple arithmetic formula or that is your derivatives or whatever may be, but thing is that formula should be there. So final step in the analytical process is to perform the calculation and report the results. So that is the job of the analytical chemistry person in a acceptable manner. That means formula should be there, by which formula you have applied, and what is the amount of that particular species is present. You have to focus on that one. Okay, in the next slide, what to let's see. Okay, now we'll come to the point. Okay, so the point is this is what I discussed with you all right now, last 40 minutes around that figure. So that what I discussed, this is the whole, what is the analytical chemistry, what you have to do, what is your job responsibility, what is the manner to find out the different samples, what is the preparation of a sample, and how the procedure is there, what are the things are there, what is how to calculate formula set, all the things. It is a part of the area that you have to record all the things. As from this part of that 40 minutes of lecture, you have to understand how it is practical, that is acceptable area of chemistry. Okay, this is the practical knowledge. Okay, now come to the point. This is that you will go to the your chapter. Okay, so this is there. So what we have discussed, that is there your chapter, as well as your career perspective point of view, why you are studying this analysis, what is the means how you are put your effective that is effectiveness in the how to give your that is 100% potential to this particular subject. So that is the thing. Okay, now we'll come to the classification of different analytical techniques. Now this is the reality. What type of things, what type of techniques we will use to that for this analytical process, right? Or this is the classifications. Okay, now the thing is that the process of development of methods of a chemical analysis, okay, is the analytical chemistry. The analytical techniques can be classified on the basis of the type of properties. Means that particular analytical techniques, whatever the method process, it will depending upon the properties of the different that particular sample. So that on the basis of that we can what is that classify these particular things. So first process is chemical method of analysis. I told you that that a particular three classical method was there in the chemical method, then that a physical method and a physico-chemical methods. Three major methods are there. On that basis of that, we can now elaborate these things. First is chemical method of analysis. Second is electrical method of analysis. So chemical method, I told you, by adding up different chemicals and all the things you have to do. That is the classical methods. It was later earlier in the stage, right now, and it will be. No one can replace this one. No machine can replace this one. Then we can understand the electrical method of analysis. What is the electrical method of analysis means? I will go to that slide. Okay, we'll go to the slide, we'll discuss over there. And the third is optical method of analysis. Fourth is nuclear radiation method of analysis. Fifth is thermal method of analysis. Sixth is separation method. Individual method we have to understand. We have to understand what kind of equipments you can use, what type of processes are there. So in next slide we'll go to that. Next slide. Now chemical method of analysis means you have seen that in that previous slide, that is the first one is the chemical method of analysis. Now I have to elaborate this chemical method of analysis. What is there in chemical method of analysis? What is there in chemical method of analysis? What we have to study in the chemical method? How we have to do? What kind of equipments used in this case? Okay, by this method, direct mass can be calculated by using two procedures. Honestly, I told you in the very beginning, the analytical chemistry means to find out the mass of the particular substance, particular species. That is our target point. It is in gram, milligram, kilogram, whatever may be thing. So, but we have to find out the mass of that particular substance. If If you say that if you ask about the cadmium chloride, what is the amount of a cadmium in that particular species sample, what is the amount of a cadmium is present, so you have to find out in the gram, milligram, or kilogram, whatever things. Okay, that is the main motto of this analytical chemistry. So we have to find out direct mass. Chemical method of analysis means that is the, see, this is the important thing. Chemical method analysis gives us the direct mass of the particular species, particular sample, particular thing. Okay, so in that things we have to use two different types of procedures. One is gravimetry and second is volumetry. Okay, one is gravimetry and second is gravimetry in the form of the gravitational separation, volumetry in the volume sensor. Okay, so we'll elaborate that one in the next. These two methods are developed by at early stage and based on the primary role of the chemical reactions. So these two methods, it is there in the earlier stage. I told you chemical method. It was earlier in the ancient time. If you go before your birth period, you are a young one. If you go to the before your birth period, so there is this method. Right now, it is also we are using, and also tomorrow you have to use this method, right? These two methods are developed at early stage and based on the primary role of a chemical reaction. How the chemical reaction happened, how the means moles is present in that what type of moles are present. So on the basis of that one, so these two procedures just work on. Okay, so if we go to the next slide, we'll understand gravimetry. Okay, in this slide, we have to classify the gravimetry. What is this? How it works? Details we'll read about this and follow the things. Okay, nice. So it is means analysis by weight. Means weight, on the basis of weight, we have to follow this process. This process on the basis of weight. Final results are often by means of the analytical balance. You have to using analytical balance, then you can calculate the mass. This is the procedure. Third point, what is gravimetry? Is an accurate macro analysis procedure. It is the macro analysis procedure. Means if amount is more, then you can use this gravimetry process. Okay, amount is more. Next, depends upon the precipitation of an ionic or molecular substance on the basis of the chemical reactions. I told you, if you put the zinc and you will add zinc chloride, zinc, you will add HCl, hydrochloric acid, then what will happen? Zinc chloride precipitation will form, the hydrogen gas will be evolved out, right? So you have to filter that out, that zinc chloride. Okay, then liquid will be separated out, then you will go and weight this one, then you get the amount of what is the amount of that a particular thing is present over there, right? Next, third, it will come to the next point. The precipitate is then separated, dried, and washed in the suitable form. So we just use in the suitable form of this one, because that thing is that you know that in the few that classes back you have done the crystallization. So crystallization process is a gravimetry process, right? So copper sulfate, you have done the copper sulfate solution. You have to then you have to make the solution. Then you have to filtrate. Then you have to crystallize. Then you have to mother liquid will filter out. Then you will get the amount of that particular substance. Then this, what is the mass amount of that is you have to calculate. So that is the gravimetry process. Next thing will come out, the precipitate will be separated on top. Next, the amount of a desired constituent is then determined by the simple calculation. Okay, so that you have to calculate by using the suppose I have given that barium sulfate. So barium sulfate you will take and you will diluted it this one. Then you have to filter it out. Then you have to crystallization process. Then mother liquid will tinctured. Mother liquid will be separated out. Then what will amount will there? You have to calculate. That is the gravimetry process, right? Okay. Next, if you go to the next slide. Okay. Next, we'll understand the volumetry process, right? So measurement of the volume of the analyte is in the volume. Volume means it is the liquid part, right? It is not in the solid state, it's the liquid state. And I earlier told you that all the things are in the what is that? You have to make the sample bring into the liquid format. Then you can do it. Okay. Based on the concentration of reagent solutions, advantage of this given method over the gravimetry. So as you are using here that liquid, we have to using the reagent. On the basis of reagent, so gravimetry and volumetry will choose best method. That is volumetry method is the best method. Titration, you can say that method is the best method. So this you can give over the, means it will get preference over the gravimetry. Okay, this method is called the titration. I told you that this method is called titration. Is the, it's a classical method, it's the super method to find out any kind of things. So titration is the super method. Titration is the, honestly I told you, titration is the best method. So volumetric method is the titration, and you are well customized with this method earlier. Okay, next, volumetric method is just much simpler than the gravimetric method. Exactly. So titration, if we compare the crystallization and titration, so titration is the best one over to the if we go to the crystallization. Okay, next method, if we go, next method we will understand. So that volumetry, if we calculate this one, so volumetry means that will come to the point, measurement of the volume by of the analyte. So what is the particular component you have to find out? Through the volume calculation, you can find out the amount of that one. What is the mass present over there? Just a second. Okay. Then based on the concentration of reagent solution, the greater the best the based on the concentration reagent solution. Okay, so we have to use the reagent, what type of reagent, what is the base of means behavior of that reagent, how it will be, it will affect to the cationic part or anionic part. Okay, so that means on the basis of that volumetric calculation will be there. The greater speed of a volumetric analysis is an important advantage of this method over the gravimetry. Okay, so volumetric method is that, you know, that it is liquid part, and over that, on that basis of that one, so that is kinetic energy will be more in this case of particles. That's why the quick reaction will be observed, and it will be faster than the gravimetric process. This method is called titration, as I told earlier. The volumetric method is much simpler than the gravimetric method, as I told it. Okay, next, we'll come to the point. Next thing is that if we go to the, refer to the slide number 12, what I show you to slide number 12. So refer to in that, my second process is electrical method of analysis. Electrical method of analysis. So this is the first one, is that your chemical method. Right now it is the electrical method of analysis. Okay, in the electrical method of analysis, what type of things we'll use here? So in electrical method of analysis, an electrical method analysis, also known as electroanalytical method. So both are same. Electrical method of analysis, electroanalytical method, both are same. So name is only the different on the basis of that behavior and all the things. Okay. In this method, an electrochemical property, you know that electrochemical property means redox reaction. Okay. Electrochemical property of a solution is measured. Next, by measuring different electrical quantities such as potential, current, quantity of current, you know that electrochemical chemistry means that particular redox reaction. In this case, resistance, that conductance, dielectrical constant, electroanalytical process. So this electroanalytical process depends upon these various factors. How the current, see, if we'll check it out, if we'll give an example here, we are usually that electrical cables, electrical wire, they have the copper, right? Why not iron? Why you are not using iron instead of a copper? Because copper has high electrical conductivity rather than the that is iron. Iron have more resistivity than the copper. So if you understand these things, so you can find out the behavior of that particular that elements or particular compounds. So electrochemical method or electroanalytical method is also an important method for this one. Okay, next slide, we'll go, we'll elaborate this one. Okay, now in the electroanalytical method, we have we have used different type of equipments, different types of process are there on the basis of measurement of these quantities like current, dielectrical constant, then resistivity, conductivity. So different quantities are there. So electrochemical methods has the following names: potentiometry. One, the potentiometry is there. Second is amperometry is there. Third is voltammetry is there. Yeah, all are, you know, the voltmeter. On the basis of that, coulometry is there. So coulombic, that constant or that meter is there. So conductometry is there, and high frequency methods are there. We'll read each and everything, every segment we have to read. We have to understand what is their behavior. It is in your syllabus. It is what is their behavior, what is the facts associated with this one. Everything we have to understand, everything. Okay, so now we'll come to the next slide. Okay, now this is first one is potentiometry. In front of you there is a picture. Check it out, all the picture. Okay, first you have to check the picture. I told you this is a redox reaction. As you know that, I told you redox reaction is there. Electrochemical properties. You know that flow of current is opposite to flow of electron. So behavior means electron flow is good. It is in good speed. Then current will be good in the good speed. If electron movement is very less speed, the flow of current will be less. So resistivity is high, conductivity is less. So this is the scenario. Now we'll check it out. One that a graph is there. Okay, and in that the point one is measurement of a potential difference. What is the potentiometer? What is the job? What is the work of that particular process? What is particular process? What we will do? So potentiometry, measurement of potential difference across an electrochemical cell. If the electrochemical cell is there, you know that redox reaction, oxidation half and reduction half. So then flow of electron will be there, and the flow of that is current will be there. So electrochemical cell to interpret the result of an analysis and designated by the term potentiometry. Potentiometry means what is the potential difference. On the basis of that we can calculate. Okay, if you go to the next slide. Now check it out. Potentiometry, what is the principle is associated with the potentiometry? What is that calculation? What are the means mathematical formula you have to put to calculate this one? Okay, potentiometry principle. What type of principle based on this potentiometry? So potentiometry states that the change in the potential difference between two electrodes. Potential difference, you have to understand that, you know that better in the electrochemical series there. So one having that electrical conductivity is something, and another will be the higher low, whatever maybe, that is what are the difference between there. So that is potential difference. You have to understand that one. Okay, so on the basis of that potential difference, by using the potentiometry we can understand that what is the potential difference between these two. If potential difference is there, one will be oxidizing and oxidation reaction, another side will be reduction reaction. So who is where that oxidation and where is reduction is there, which is the oxidizing agent, which is reducing agent. So on the basis of that you can calculate what is the behavior electrical conductivity of this one. It determines the analyte's concentration by the change in the concentration ions. So means flow of ions from the that a potential difference will be there, means flow of ion will be higher to lower will be there, or lower to higher will be there, current and that is ions. So in that ion, where the ion movement will be there, so that ion will deposit somewhere else. So then electrical conductivity will be there. There is a potential difference. Actually the things will not done by this. Some ions will go, some ions will be actually what happened, the concentration will be blocked, some ions. So mechanism is something different, but potential difference is the main point to calculate by using this potentiometry that techniques. So we have to calculate the potential difference, then we have to find out the what is that actually that concentration difference, and all the on the basis of that on. So we have to calculate the, I have to analysis that what is that What is the potential difference between the two? Okay, then how to calculate the potential difference? So there is a formula in front of you, potential difference formula. So that is, we can calculate the total electric potential or the potential difference as E cell is equal to E. See that all the that abbreviation is written over there. E cell means potential of the whole cell. EIND means potential of the indicator. EREF means potential or electromotive force of the reference electrodes. Which electrons you are which electrode you are calculating? EJ means salt freeze, function of salt freeze. The formula is written over there. So E cell is equal to EIND, next minus EREF plus EJ. So all the reference is mentioned over there. The measurement of electrical potential depends on the concentration of the ions and contract with the indicator electrodes. So you have to find out which reference you are taking out. This is the process. You will see that if you go to the before slide, means this one, check it out. So this one is you have to zinc. You have to zinc here, one electrode here. That side is copper electrode here, and voltmeter is over there. That KCl and that HNO3 is salt freeze is there. So you have to take zinc, refer to the copper, and copper refer to the zinc. So that is the process here. Okay. Now, if we go to the, what is the importance of this potentiometry? How the potentiometry is important to calculate all the things. So, if we see the importance of a potentiometry is the analytical chemistry is to determine the concentration of the solute in a solution. So, the work of potentiometry is to find out the concentration of the solute in a solution. So what is the concentration of that solute in that solution? You have to find out. Okay. Second, the pharmaceutical industry use in it is as a weight percentage assay for the small molecules active pharmaceutical ingredients, intermediate and raw materials. So the potentiometry has the great role in case of pharmaceutical industry. And you have to understand this process has importance in case of the pharmaceutical industries. Okay. Next, you have to move. Next slide. Amperometry. Okay. On the basis of that, you have to see the amperometry that the process is over there. What is the amperometry? And the amperometry involves the measurement of the current. As you know that this is the current related particular procedure. So amperometry is related. Amperometry involves the measurement of the current at constant voltage applied at the dropping mercury electrode. So that that is a technical part is here. I'll come to the next slide. If you go to that one, if you go to the next slide, you have to understand that one. See, okay. Okay, next. So thing is that constant voltage you have to maintain. You have to maintain one constant voltage. So constant voltage have to apply it. And what is the dropping? How the mercury is deteriorate in the condition to the that when you supply the constant current, so mercury will be going down. And in this particular equipment is there, you will see that constant voltage will be supplied. Then that mercury will be lowered down. So in this case, that particular things we will have to calculate. So the things is that the value of electrical potential is chosen in such a way that only the metal ion is reduced. So only that in this case metal ion should be reduced, not non-metal or any kind of you will say the hydrogen electrode is not possible also. Then what will happen? This method is generally used for the determination of metal ion present in the aqueous solution. So only for the metal ion this kind of this amperometry is used. So I told you that in the when I started my chapter, particular procedure is used for the particular work. So you have to understand what type of things you have to calculate. You have to analyze the everything. What is the define? Your definition is most important. What is the procedure is, what is given, what to find out, what procedure I have to follow. So everything will be a schematic way. So on the basis of that's why we are reading each and every procedure. So amperometry is used for only the metal ions. where there is calculation about the metal ions, so that electrical procedure is there, metal ions are there. So in this case amperometry is used, but not for the all. Okay, if you go to the next slide. So amperometry, okay, amperometry has a great role. By amperometry, this is actually the thing is that, just a second. Okay, actually the thing is that amperometry has another name. It is actually bioamperometry. What is bioamperometry? Means this is the thing that in bioamperometry titration, that a small constant voltage. I told you amperometry means you have to put that a constant current, supply of a constant current. So bioamperometry, it actually this is used in the biological science, and this is most important thing. And that's little a small amount of constant voltage you have to supply to identical electrodes, usually of platinum. Here you can use, okay, and the current is measured. So significant current flow is possible only from both electrodes are depolarized, okay, such as in the solution that contains iodine or iodine ions. So this is very specific. This iodine you have to use, and also both having that platinum, that platinum electrode you have to use, and the very small amount of you have to see. This is a very precaution step. You have to understand the procedure, what to do in the by using this procedure, which is actually essential, which is not essential. If will give high voltage of current, that is not acceptable in this bioamperometry. This you have to very small amount of current constantly you have to flow. So that is the essential. You have to understand the procedure. What exactly we have to do in the different procedure. Okay. Next, iodine is also used in this case. Next, application of amperometry. If you go to the application part of the amperometry is one of the most widely used technique in bioanalysis. When I started about the bioamperometry, so I told you this is biological, in the segment of a biological field. So bioamperometry has a vast application right now. So we have to use this bioamperometry or amperometry process in bioanalysis. Second, what to do? To date, it has been utilized in 3 core areas. You have to understand what is the importance of this one. 3 crores of areas bioamperometry. These include the detection of a chemical transmitter released from the cell. So cell biology is the most important area of the biological science, and how the behavior of the cell biology and all the things will be connected. So here, these include the detection of chemical transmitters released from cells. Next, it is used as the mode of detection of the various types of biosensor. See that what is the important areas use of this amperometry, and which area I told you when analytical chemistry I started this chapter. I told you what is the means work perspective of this one. If it 3 crores of areas you are using this bioamperometry, if you understand proper things, then you can go that in the long top. Okay. Next, what will happen? Next slide. If we go to the next slide, then voltammetry is the another one. So in this case, voltammetry is the technique that studies the current responses of a chemical, and potential difference is applied. Current, potential, and difference applied. It involves electrochemical cells and investigates reactions that occurs at the interface of the electrochemical electrometry. So that electrolytes, you check it out. This is actually that one process. Voltammetry is a technique that studies the current response of a chemical when a potential difference is applied. Okay, what is the difference of a current is actually find in when you applied this one, that voltammetry, that the potential difference, what is caused when current responds to the chemical when the potential difference is applied. If different potential difference will be applied, what is the response of current? Response of current towards the potential difference. That is the process in this case of a voltammetry. You have to study it. Okay. Next, use of voltammetry. Voltammetry is a technique used to detect neurochemical capable of undergoing oxidation reactions. I told you these are all most of the oxidation
Hello.
reduction react. Hello. So oxidation reactions, these neurochemicals include neurotransmitters such as serotonin. Okay, this is the use of that is neurotransmitters. That all the things are chemical use of this one. So you have to use, on the basis of that we can do the practical also. Next, the next technique is coulometry. Okay, what is the principle behind this? The principle behind coulometry is the basic principle of coulometry is to measure the quantity Q, means current quantity of electricity, which can be regarded as the integral of the current, and time passes T. So within stipulated time, what is time, how much current is passes and what a mass is deposited. On the basis of that, we can calculate. This is a coulometry, is the technique principle based on that one. Coulometry is performed by the general two techniques. What is coulometry at a constant potential, known as the potentiostatic coulometry, and second is coulometry, it may be in your exam. So coulometry at constant current, known as the amperostatic coulometry. So these two techniques are based on that, on the basis of that coulometry is working on. If you go to the next slide, use of coulometry, where we can use this one in clinical chemistry, and also, so it is used, coulometry is exclusively used for the determination of a chloride concentration. Next, for the application of coulometry in sufficiently specific, this particular process is a very specific process. One thing is that you have to calculate the that how much amount, what is the concentration of the chlorine is present in the particular solution. Second is the sufficiently specific. What is that? Because of concentration of other halide, it is usually very low compared to the chlorine concentration. So it behaves only that behavior towards the chlorine rather than all other halogen like fluorine, bromine, and iodine. So this is very specific for this one. So that's why you have to understand. Then conductometry. So another thing is there, another process is there, that is conductometry. The principle of conductometry is based on the fact that during our titration, one ion is replaced by another. So in case of titration, that which ion is replaced by which ion, so that will be calculated by the conductometry. So the difference in this ionic conductivities of these ion directly impact the overall electrolytic conductivity of the solution. So when one ion is replaced by another ion, so that will has that impact on the conductivity of the current and the electricity, whatever there. So that's why if it has impact on this situation, so we that ion transmission can be that is very means affected. So then what will have, that conductometry will be calculated that one. So conductometry is performed in two different ways also. One is an analysis can be computed directly from the conductance measurements. Second is conductometry is applied to the determination of the equivalence point of the titration. That conductometric titration is known as this one. So these are the conductometry, that is how the conductometry is working on and all things. Next, if we move to the use of conductometry, so conductometry is used to analyze ionic species and to monitor a chemical reaction by studying the electrolytic conductivity. So how the electrons that means one ion is transmitted to another ion. So after that, how the conductivity is affected. So that can be calculated by this method, analytical conductivity of the reacting species of the resultant products. It has notable application in the analytical chemistry. Okay. Next, high frequency method, and this is the mostly last method of that one, high frequency method. It is the conventional conductometric method Conductance measurement are made by using the alternative current at relatively low frequency. If you use low frequency in the conductometry, it is actually the high frequencies, high amount of electrical conduct that electrical current will be used. So that so that is the speed of the that ions will be high. Then on the basis of that we can calculate. So high frequency of that is method. Okay. Then use of this one. This method can be applied to the measurement of a dielectric constant and also for several titration where the electrode do not come in the intimate contact of the solution. So this is the use of that on high frequency. Okay. If we go to the next, the third part that we have finished, that is chemical as well as electric current of that one, use of that one. Third, if we go to that, this one reference to the slide number 12, optical method of analysis. So two methods of analysis we have understand under that. What are the subtopics were there, what the process techniques were there, we have discussed. Now the third process is there, optical method of analysis. What to do in this case? What is the optical method of analysis? In your course, that is 003 MCH of this program, you will actually that these that electrical that is techniques as well as chemical techniques you have already studied in the your particular in the last previous degrees. So we have to start, actually this is the that main target, main objectives of that one. MCH-3 program, MCH-003 program will have the study, will have provided you the vast area to work out on the optical method of analysis. This is the actually area of study here. So later that before you have already studied, that is your titration, you have already studied that gravimetric process, you have already studied. So this type, your electrochemical reaction, you have done the practicals and all the things. But this optical method, you have to, this the measure areas. Now we have concentrated on the MCH-003 program. These methods are now called as the spectroscopic methods. Actually spectro thing that graph will be there. So from that graph we have to sample is there, we have to go through the spectroscopy method, then graph will be come out. So from that graph we have to find out what is the composition over there, and on the basis of we have to statistically understand what is the what areas are there and what kind of behavior of that particular substance is there. So that spectroscopy method is there, and in this optical method of this particular analysis we have to understand the spectroscopic method. So these methods are now called as spectroscopic method of analysis. In this method the first instrument were developed for use of the visible region, they are called as the optical methods. Under the spectroscopy method you have to that particular one instrument is used. So in that instrument you have to understand the visible layer. Okay, our optical nerve can observe particular lights, that behavior you know that. So but there is a frequency level, so that within that frequency that particles we can see, we can through our optical nerve. So that's why it is the optical analysis method, means we can see, we can analyze, right? So that when you will go to the spectroscopy, you will tested particular some substance, it will give some visible areas of lights, so we can observe what is the behavior of that one. Like suppose if you heat that sodium, it will gives the yellow color, and if you zinc oxide, if you heat, it also gives the yellow color. So that means we can analyze. Okay, so someone is screen is not showing. Are you getting the screen?
No, sir.
No, sir, no, sir.
No. Okay, just a second. I'm second time I'm just sharing. Just a second, please. All of you, no one has seen the screen.
No, sir,
Sir,
no. Screen
I
is
am
there.
able to
Let
see.
let let me do again. Let me do again. Is it visible right now?
Right, sir. Visible.
Okay, that's good. So, okay. So, if we go to the optical method of analysis, MCH-3 program is that elaborate this process. As you know that already that volumetric process, chemical process that we have already studied in that titration method and crystallization methods. That's why it is just overlooked there in the syllabus. But that also electrical method is the electrochemical series is there, and electrochemistry you have done the practicals over there. So, but this optical method means this is actually the things. So we have to understand. Okay. So in MCS3, this method is elaborate and practical. Perhaps you have to do this one. So these methods are now called the spectroscopic method. Have you that if you visit to the gold jewelry shop nowadays, jewelry shop, big jewelry shop, so you'll see that they are not using any kind of things. They are using the spectrometer. They're putting the gold inside the spectrometer. That analysis, what is the percentage of means how it is pure. That 99%, 100%, 98%. What is the purity of that gold? That spectrometric graph is coming out on the basis of that one. The graph analysis, we can get the what is the means gold purity of that one. So spectroscopy has a vast right now. Using of that one is a vast area. So directly we can use it. Okay, is there any issue, Mr. Rishikesh? Okay, so this method is actually that optical method, because if you see that in early stage, so this particular we can see this particular vib gear is there. So 7 colors are there. So that can be that identified by our eyes. So that's why this is optical knob. So on the basis of that one, early stage were there. Right now, if you go to the modern techniques, so right now it is not like that. It is that graph is there, and on the basis of the graph we can calculate, not always by using our eyes. So what is spectroscopic method? So spectroscopic method are based on the interaction of the electromagnetic radiation with the quantities, energy states of the matter. See, actually what is there? Just a second, I do have one. Then the thing is that, so that what is the spectroscopy method? Spectroscopy method are based on the interaction with the electromagnetic radiation. See, that is you have learned about the structure pattern, and there is radiations. You have learned that one. What do you mean by radiation? Actually, radiation is a term now it is common. Due to radiation, that is temperature is increasing, right? So we are using frequently the radiation. Maybe the science student or not, that does not issue. That when temperature is increasing nowadays, people attend due to radiation. So symmetry, building construction, high symmetrical buildings are there, so radiation is high. Due to that, we are feeling so hot in these areas like that. Okay, so radiation is a common topic right now. But thing is that in this case, what will happen that electromagnetic radiation, this is a procedure, this is a complete procedure, how when the light particles will fall, what is the behavior of that one. See that photoelectric plate, when the light particles fall, then what will happen, the electrons will be released, high frequency, that is electrons will be released. So in this case, what will happen, that see, this is a type of radiation process, but exactly not, we'll go to that what process is there, what type of things will be there. Okay, now we'll come to the point. If we come to the next one, the principle, we study the measurement of a quantity based on emission. So emission is a technical term. Spectrum emission of spectrum, right? It's a technical term. So if that emission, absorption, see, this is a particular area. What are the procedures are there, by using which procedure, which that fact we can that analyze these things. One is emission, second is absorption, scattering or change in the some properties of electromagnetic radiations EMF, right? So depending on the nature of the amount of a constituent of the sample, so it depends upon, actually not, see what is the, see, you will see that in the traffic post, I will go to the very small example and common example, that it will traffic, three different types of lights used: green, then red, and then yellow, right? So all three lights is for stop, that is red. Okay, so why stop, that is red, and why it is that green for the go? So thing is that due to the wavelength or frequency. So like that, on the basis of that one, analysis of that one, we can share the things, we can understand the things, what is the, we can behave, we can analyze the behavior of that things. Okay, next thing is, we'll go to the point. Next slides. Classification of optical methods of analysis. So on the what is the actually, how can you classify these things? So classification of optical methods of analysis. On the basis of that, so optical methods of analysis can be classified into two major types. Okay, first one, the type of effect. What is the type of effect? Like emission, absorption, or scattering. So this is the one type of these three things, on the behavior of these things, like the three particular effects. And second is the type of EMR. Okay, X-ray, IR, infrared. What are the processors there, on the basis of that used, by use of that one? These two types of things are used. On the basis of that, we can classify the optical. So what are the methods are used in spectroscopy? So emission spectroscopy, then absorption spectroscopy, then ultraviolet or visible absorption spectroscopy, then in IR spectroscopy, infrared, then photometry effect, then turbidity metries, and that effect, that is another things, and Raman spectroscopy. These are the methods we have to understand. These are the methods particularly used in case of this spectroscopy methods. Okay, now come to the emission spectroscopy. Okay, first one is emission spectroscopy. So let's understand the emission spectroscopy. Okay, if you come to the emission spectroscopy is a spectroscopic technique which examines the wavelength of the photon emitted by atoms. First things you have to understand, emission, what is the job of emission? You know that emission in the structure of atom. So emission is that spectrum, it's a type. Emission means this is wavelength, related to wavelength. Okay, wavelength of a photon emitted by atoms. So when atom that emitted the photon particles, so what is the wavelength of that? That will be measured by this particular emission spectroscopy. Okay, by atom molecules during their transition from an excited state to lower energy state. So what is actually that, when the atom moves, that a particular emission from that moves from the excited state to lower energy, which when the stable state will come out, what is that emission? What is the energy emitted? So that is the work of the emission spectroscopy. That particular that instrument will calculate what is the energy is there. Okay, types of emission spectra. There are three types of emission spectra. It's continuous emission spectra, line emission spectra, and band spectrum. You can say that band spectrum emission spectra. Okay. Now we'll come to the next slide. Basic principle. What are the principle associated with the emission spectra? In atomic emission spectroscopy, energy is applied to a molecule. So first, in that what on the basis of which what actually that this emission spectroscopy is formed, how the emission spectroscopy is working on. So this, by applying this energy, that energy is applied to a molecule in the form of light or heat. So first energy will be applied. This energy then excited the electron in the molecule to a higher energy level. When energy we have to provide to the particular particular atom or molecules, then what will happen? The energy level will be high. Then because energy is absorbed by the particular species, the excited state is, however, less stable than the ground state of the atom. As you know that always ground, excited, then stable format. So ground, when the ground state the atom is there, that will stable in the stable state. It will provide the energy, then it will go to the excited state, unstable state. Then it will lose the energy to come down. Then that will be the stable command. So, however, when it is in the that is in excited state, it will come to the lower down. In this particular, how much energy is associated with this segment, higher energy level in the excited state to lower down, then what will happen? That particular energy is calculated by the spectroscopy or spectrometer. So then this results in the decay of excited state. So excited state will be decay. On this basis, losing the energy, then what will happen? Come down to lower energy level. You will see the picture of this one. So that is one flame is there, and it is monochromator is there, and will pass through this, and the visible slits are there. Then anode photochemical cell is the amplifier, then detector, then recorder. This is the work of the spectroscopy. Spectroscopy then works in this method only. In this method, it will see that particular picture, and it will analyze the things. These are the techniques used, and on the basis of that, this particular spectroscopy will be work. Then application of atomic emission spectroscopy. Where you can apply this particular spectroscopy? The application of atomic emission spectroscopy, AES, you can say atomic emission spectroscopy, AES, has a wide range of application in various industries, including environmental analysis, then forensic science. If we come to the environmental analysis, what will happen? AES is used to analyze water, soil, and air sample for trace amounts of elements. What is there actually that nowadays you have seen that Delhi is suffocating with the air pollution. We are seeing that in the various types of news, right? So pupils are suffering from different type of what is that air pollutants. So what is the amount of air pollutants at present? You can calculate by using this one also. Okay. So then elements such as heavy metals, which can be harmful to human health and the environment. Means job perspective, you'll see that is this emission spectroscopy in that analytical chemistry is high. Okay. Just a second. Okay, is there any issue? Hello? What is the issue you have? Okay, that's good. That's good. Okay. Now the thing is that what is how the emissions spectroscopy is used in case of forensic science. So qualitative and qualitative analysis identifiers. Okay, elements present in the sample of qualitative examines from the ppm level to percentage. Okay, so this is the ppm level to percentage. You have to calculate what is the how much ppm. Actually, normally we can calculate in the case of ppm. Then we'll come to the percentage. So this is the difference of that one. So you have to use in this case. Okay. Next, absorption spectroscopy. So emission, after that, next spectroscopy method is absorption spectroscopy. In that, what to do, what exactly is going on. Absorption spectroscopy is a technique that measures how much electromagnetic radiation a sample absorbs. So what is the amount of that particular sample can be absorbed by, we can calculate by the absorption. You know that this terminology means smelling like that, absorption. So what is the amount of absorbed by particular? So absorption factor means what is the amount of a particular that is that spectroscopy is calculate how much amount will be absorbed by the particular substance. Okay, the method how much electromagnetic radiations or sample absorbed. Any sample you can take. So how much it will absorb the electromagnetic radiation. The sample absorb energy or photons from the radiation fields. What is the principle? The principle of absorption spectroscopy is based specific range of radiations. Anything, if you see that if you go to the soil, if you being practical, I don't have any right now in my hand, I can show you. But if you see a sponge is there, sponge, you know that it will absorb the water particles. So after a certain amount of absorption, that sponge will not absorb more water. Exactly, that is the process of this absorption spectroscopy. So a certain amount of that particular radiation can be absorbed by the absorption spectroscopy, and on the basis of that we can calculate what is that particular sample behavior of that one particular sample. Okay. So then that absorption spectroscopy use optical techniques to analyze the light that passes through the sample. Okay, a beam of electromagnetic radiation passes through the sample. Then what will happen? And most of the radiation passes through without losing intensity. Then, however, at certain wavelength, the radiation's intensity is reduced. Then, which is called absorption. So, see that if you read this statement, you will understand. When light is going on in certain amount, in certain radiation, that is in the absorption, that radiation will not absorb. Then light again intensity, same intensity will go away, but certain in that absorption phase, absorption spectrum, that particular that radiation is absorbed. So this is the, by this method it is calculated. Okay, next, use. That what is the use of absorption spectroscopy? That is clinical analysis of metal in biological fluid and tissues. Is the biological segment. Okay. Next, pharmacology. Third, archaeology. Fourth, manufacturing. Fifth, mining. And sixth is forensic. Wide range. So analytical chemistry, this particular method has a wide range of use. Next, if we go to the next slide. Okay. So anyone, if you go to the your now, if you go to your chapter, anyone can open your that syllabus. Do you have all of you? All of you have your syllabus. Okay. Now let me to go to the syllabus. Just a second. Okay. If you will go to this particular chapter, that analytical chemistry in general perspective, will go and below. Just a second. We have few questions. Okay, so some questions are there on the page number 12. If you open that one, you'll get the question. Some questions are there. The first question is there. What is the essential feature of a method to be called as an analytical technique? So the means what should be there, that the essential features, it is called as the analytical technique. If you go to the slide number, okay, slide number 2, then you can get what is analytical chemistry. Okay, it is the science of obtaining, processing, and communicating information about the composition and structure of matter. Okay, this is the analytical chemistry called. Okay, next question, if you go to that that question number 2, page number 13, sorry 19, the question number 2, name the methods that are now known as the classical methods. Which method is known as the classical methods? I told you that classical methods, the chemical methods are known as the classical methods. The chemical methods are known as the classical methods. Okay. Then, so lots of things. Are anyone has any questions? What I taught till now? You may ask any question.
Hello, I have a question.
Yeah.
So I actually joined half an hour late for the session. So I missed a lot of the session. So is there any way that I can get
So can you record that that slide?
uh like I didn't get the link for the slide.
So slide is my screen is showing, right?
Yes, yes, yes,
So
yes.
can you download that screen or not? Is it possible or not?
Uh I'm not sure if I can do that. I'm not sure like
Okay.
how to do it. Yes.
Okay. Let me see that.
So to for tomorrow's session, will we be doing the same topic or
No, 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 no,
another
no, no,
topic?
no, no, no. Topic is same, but the lecture will be different.
Oh, okay, okay.
So today,
Like we would be discussing different things, right?
yeah, absolutely, that will follow the next area. Means it will continue, but this sometimes will come on the across this across the lesson. But the thing is that the same thing will not continue. Okay, we'll proceed.
Oh, okay, okay,
But
okay.
is it better to see? Just a second. Can you take the screenshot of this one? Is it
Yes,
possible?
yes, yes, yes. I
You
can.
I just
Okay, one second.
you just take the screenshot. I'm telling you, those who have not taken any kind of means recorded the things or listened it properly, so take the screenshot.
Yes, I finished taking the
Okay,
screenshot of this one.
okay. Second,
Yes,
third,
yes,
next,
yes,
next,
yes, 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 done. Yes, 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 finished. Yes, 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 finished, finished. Yes, yes,
okay. Till this, I have finished.
okay, okay.
Some questions also there. I discussed. Questions are there in the. You have to go through that your
Textbook.
syllabus. So in
Okay,
that below there is some questions. You can
okay.
check it out. The answer of this one. Anyone? Any questions are there?
No, no, I don't have a question.
Okay. Thank you.
Okay, thank you.
Anyone else?
How to download your this one slides?
Oh, okay, okay. That no, no, no. Actually, the thing is that let me to. Can I share with all the? Okay, so tomorrow I'll do one thing. So tomorrow that lecture completely I'll share with you. Okay, you can
Okay,
download.
okay, okay.
Let me to discuss with the director, sir. So whether it is directly possible to the share with you or not, I don't know. but thing is that let me discuss with him. After that, if it is possible, so definitely I'll share, or IGNO will provide you. Okay. Okay, have you got any actually this analytical chemistry is a see, this is what I mean to say, that this particular area of chemistry has a vast field, and practically you should be handy if you want to do the career over this. So there is lots of scopes are there. I don't know that what you people are doing right now. So, but thing is that if you try to put your hand on analytical chemistry, so this is the big area and a vast area. So you can, if you have any questions over this today's topic and any things like that, so I can share something with you.
Do we have attendance for these sessions?
Yes, by default it is taken the attendance. We are
Oh.
taking the attendance.
Okay, but I joined like half an hour later, so would it be
Okay.
would
Okay,
it
we
be
will do that.
affecting my attendance?
Okay, I'll take that one. I'll take that.
Okay.
Anyone else who was having the questions, anything regarding this? Mr. Kader, do you have any question?
No question.
Okay.
Thank you.
Do you understand that actually are you in the very beginning, or that Mr. Kader you joined in the latter line?
Yes, no problem. But you are not
Okay.
explaining this other spectroscopy, NMR, IR, this one other spectroscopy.
No. Everything I'll explain. Don't worry, sir.
Tomorrow, today classes or tomorrow?
No, tomorrow, sir.
Tomorrow.
Today it's not that. 5 to 7 today was the class, right?
Okay,
And it's
okay.
going to be 7.
7 o'clock.
So that means tomorrow I'll explain all the things.
Tomorrow the same timing.
5 to 7. So this
5 to 7.
throughout this week I'll take your class from 15 to 22, right? So
Yes.
that will be every day. That is 5 to 7.
Every day. This is up to 22.
Up to 22.
Okay.
7 days continuous classes. There are only except Sunday.
Okay.
Srilakshmi, hello. Srilakshmi, are you listening me? Srilakshmi? Okay. So I just that is let me to discuss with the directors of IGNO. So your solution, Bhubaneswar IGNO. So if you will give me the permission, then I will share with you all the slides, or else IGNO will provide you.
Okay.
Right?
Okay.
That officially let me to take the permission from him. Then
Okay.
so some students are asking for that slide and all the things. Definitely I will, but let me to talk to him. Okay. That's fine. Do you enjoy the class today? Anyone has any issues?
No, it's a nice class. It's a good class.
You joined late, ma'am.
Yeah, I joined
No
half an
problem.
hour later.
No problem. Okay, no, students are telling no, sir, good class. Okay, that's fine. Mr. Chandan, you have one query, right? You have to make a WhatsApp group. See that it is not possible for me, so I need to take the permission from the director, sir.
Yes, sir.
Okay. Any issue you can ask me. So, but thing is that today, see that I have taken the class today, and you don't know to me, I don't know to you. So that's why I have a little bit 5-10 minutes before I just conclude my classes. And thing is that we have to interact with some facts. If you have some issues and all the things, you can share with me. Then we can sort it out. Okay. Mr. Amba. Okay, no problem. Okay, so we'll take your attendance. That is not the issue. Very good. Thank you all.
Thank you, sir.
It is most
Thank you, sir,
important
for
thing that it is most important thing you have to understand that thing. Okay, so actually this is a practical best that subject. So I just explained that in the theory. So when you go to the practical, you have to understand what is the use of that, actual use of that thing. But as you know that you have a theory paper, you have to sit for the examinations. So okay, that is the most important thing.
Yes, sir, regarding the assignment, is it okay if we write answers like from the textbook, or do we have to write it in our own
See,
words?
see that thing is that aside, see that actually that your syllabus has some questions, right? I'm telling you honestly.
Okay.
You just go through the syllabus, right?
Yes.
Below that there is some questions. So you just first you have to do that questions, and I am damn sure that you will get all the answers what I'm giving you lecture. So over that, from that you will get all the answer from that area. Okay,
Okay. Okay.
and if you follow the last that few years questions or something like that assignment you will get, so all the things. So if you follow the lecture you will get all the things from
Okay.
that only. There is no need to go anywhere else. And
Okay.
also your that is what syllabus is providing by the IGNO itself.
Okay.
That's
And
also.
for the assignment, do we have? Can we submit it online, or we have to write it in
So
paper? And
you have not received, have you received any kind of means mail or anything else from the IGNO, your or from the study center? You are assigned with the kit, right?
uh, means I
Kit,
don't.
you have kit study center, right?
What is that?
You are you are people from the all India. Okay, okay. Sorry. I'm sorry. You
Okay.
are itself. Okay. So that which study center you are in? You are attached with which study center?
Trivandrum.
Okay, Trivandrum, right? So
Yes.
you will consult with the study center, right?
Okay. Okay.
So
Okay.
if you consult with the study center, then we will provide you the right information. You consult with them.
Oh, okay.
They
Okay.
will provide the assignment and all the things.
Okay. Okay.
Okay. Anyone has any question?
No, sir. Thank you.
Okay. Thank you very much. So thing is that actually that this I'm going to say one thing. So I'm going to say one thing before concluding the classes. So you have choose a very good area of chemistry, right? Very good area.
Yes.
And it has a vast, if you enjoy that chemistry, you can actually, this area is analytical chemistry is the area where you can get the much more that what is facilities to work, and you can enjoy the chemistry here in the particular area, analytical chemistry. So this is a very good subject, and I hope you people have the very good that future. So thank you very much for all. Okay.
Thank you, sir. Thank
Thank
you so
you.
much.
So today I am leaving. So next day, tomorrow also 5 to 7 is there, and we will have the that we will go